14th Sustainable Development Goal, Life Below Water, states that by 2025 we need to have prevented and significantly reduced marine pollution of all kinds, in particular from land-based activities, including marine debris and nutrient pollution. There is one particular material that is seriously jeopardising the potential to achieve this. This material is plastic.
Throughout my degree, the issue of plastic pollution of the marine environment has essentially become a modern-day epidemic. It's currently estimated that on average each year 8 million tonnes of plastic waste enters our oceans. And this can be through people littering, not disposing of plastic properly, leaving plastic litter on beaches, or plastic being accidentally spilled at sea. And so plastic debris in our oceans breaks down into smaller pieces of plastic due to wave action and UV light. And these tiny pieces of plastic are known as microplastics. Recently, these microplastics have had a lot of media coverage, with cases such as microbeads used in cosmetics and also the discovery of microplastics in the guts of fish from the English Channel. Having grown up by the sea, research like this has really begun to catch my eye. And while studying at the University of Southampton, research was published showing that microplastic pieces have been found in sea salts from China. Sea salt is such a commonly used everyday item that billions of people would be consuming worldwide, and so I wanted to find out if this was happening closer to home. So I decided for my dissertation that I would look into European sea salts to see if the same thing was happening, and whether the plastic levels found in European sea salts were similar to those of Chinese ones. So I embarked on a 9-month research project to look into this, and I purchased 14 packets of sea salts, all different brands, and they were all produced from European seawater in different locations around Europe. And using various methods, I dissolved these salts and filtered them to collect the microplastics from each sample. This was a lot harder than I had initially anticipated, as I had to make the lab a plastic-free environment, and this meant that I had to be careful of what apparatus was used, who came into the lab, and also what I was wearing to avoid airborne fibre contamination. The results that I discovered were definitely shocking. Not only did European sea salts contain microplastics, but the numbers found were alarmingly higher than the sea salts from China. And looking into causes for this, a hypothesis that seems extremely likely is that European microplastic levels are much higher than Chinese ones due to the Gulf Stream. The Gulf Stream has been proven to contain very high concentrations of microplastics, and so it's thought that this ocean current is bringing microplastic contamination into Europe, and hence we are finding it in our sea salts. I also looked into the production methods and areas of each sea salt type, and high correlations were found between samples with high microplastic contamination and areas where aquaculture such as fish and shellfish farming occur. And analysis of the plastic types I found shows that in these areas, microplastics found are actually fragments of a type of plastic used in fishing nets and twine. So I'm currently on the north coast of Cornwall, and we've been having some really high spring tides recently, and with it these spring tides have been bringing in loads of marine plastics. So what we're going to do today is we're going to head down to Penhale Beach, and we're going to do a quick beach clean with some volunteers from the environmental charity Surfers Against Sewage, and we're going to see what type of stuff's been washing up on the beach, how much of this is plastic, and also have a look at what types of plastic could be ending up in our sea salts when they break down in the ocean.
Found a Australian gold base stick sun cream. This is from 2009 and it's made in the Netherlands. So it's just showing that these plastics really don't break down and they're going to stay in the marine environment for a long time.
So this is the result of a 5-minute beach clean on a section of Cornish beach that's roughly 100 feet long. We definitely didn't get all of the litter. As you can see, the majority of the litter is plastic. We've got a lot of fishing gear that's probably been lost at sea. We've got some plastic bottles, some shoes, and also some plastic food packaging. This was all picked up by us in only 5 minutes, so you can begin to imagine the scale of the issue around the whole of Europe.
This research is really important for surfacing and sewages. It allows us to understand how microplastics can start impacting humans, and it can allow us to demonstrate to members of the public that it's not just animals that are affected by these small bits of plastic. It's really easy to show how large bits of plastic can be found on our beaches and how it can harm and impact animals, but actually we don't really know how it can harm and impact people. By showing this to the general public and by talking about it, we can start to make them more aware.
Obviously, this research has found some quite shocking stuff. Not only are we consuming microplastics directly through an approved food product destined for the human food chain, but this emphasises the true extent of the marine plastic pollution crisis. So this leaves two questions. What else from the marine ecosystem is contaminated with microplastics? And is it too little too late? That's something we unfortunately can't wait around for to find out. My intention is for this research to be published and publicised as much as possible to members of the public so that people can not only begin to make conscious decisions about food products they're purchasing, but also to raise awareness of the situation underwater in our seas and oceans. We can achieve the 14th Sustainable Development Goal, but we need everyone worldwide to be aware of this issue and to make a few small lifestyle changes to begin to wean ourselves off plastic.